Hello, we're going to be doing the AP Calculus BC 2019 problem number 2. Let f be the function defined by f of x equals x cubed minus 3x squared minus 9x plus 11. At what value of x does f attain a local minimum? So this right over here is a graph of a cubic, so I'm just going to sketch out something that it might, in theory, look like. We'll say it looks like this over here. So this is the local minimum right at this point where its derivative is 0. But we also have to look out for its local maximum where the derivative is also 0. So first I'm going to take its derivative and make sure that I find this point and not that point. So f prime of x, that's going to equal 3x squared minus 6x minus 9. And now I need to factor this and find its 0. So first I'm going to factor out a 3. Then I have x squared minus 2x minus 3. Now this can be factored. I'm going to do my own little trick over here. Okay, so it's going to have a minus and a 1. So it's going to be x minus 3 and x plus 1. So now, this has two zeros, one at x equals negative 1, and another at x equals 3. And so, one of them is going to be the local minimum, and the other is going to be the local maximum. Now, we need to find out which one's the local minimum so that we can answer the question. So, to do this, we're going to go over and we're going to draw a sign chart, SIGN, not SIN. And we're going to have all of our major points over here. We're going to have, first this is 0 over here. We're going to have 1 over here. And we're going to have, we're going to have 3 over here. And we're going to have negative 1 over here. So these are all the important values of x. So when x is like 4, 5, 6, this thing's going to be positive, right? And now when x is between 0 and 3, let's say 2, this number over here is going to be negative, and both of those are going to be positive. And so there's only one negative, so it's going to be negative over there. And now between negative 1 and 0, this is going to still be positive, and it's going to be the same thing. But when we have like negative 5 or something, this is going to be negative, and this is going to be negative, so we're going to have a positive over here. Okay, so for it to attain a local minimum, you can see that the derivative goes from negative to being positive. So we need to find where the derivative goes from negative to positive. We see over here that at 3, the derivative goes from being negative to being positive. And if we want to find the local maximum, we'd say the derivative goes from being positive to being negative. So that would be negative 1, but we just need to find the local minimum. So the answer is 3. Thank you very much for watching, and goodbye.